Okay, even though you're looking directly, hi guys, even though you're looking directly at the periodic table here, I put the recording that you guys can't see. It's actually focused on this part. So when I write this stuff up, because I can't quite get the entire periodic table in where I'm at with that, but it'll do, okay? So what I wanted to do today is, like I told you guys, I haven't looked to see if everybody, attempted it and tried. I hope so. But I wanted to go over the worksheet that we began, or I asked you to practice on Tuesday, which was this one, okay? And I wanted to go over that with it, and it had a lot of parameters over basically 4, 1, 2, and 3, everything except the moles to mass conversion of simple either dividing or multiplying using the molar mass or the atomic number mass of the element, okay? So I'm going to go over, all right, the worksheet with you here, and then if you miss some of the questions, I'll scan my answer key like this if I talk quickly or you got a lot of scribbles with that. But like I said, remember I'd asked you guys, which I've on the honor system, I haven't checked, but I said even if it's all wrong, whatever, I wanted you to attempt, obviously, and submit it before class on today. So hopefully you all did that, okay? In a perfect world, which would be nice to think. We're half full here, but I'm going to go over this, okay? All right, so hopefully you have your worksheet in front of you here and looking at it, and obviously behind me is our standard periodic table here, okay? So one of the biggest things is just remember reacclimating ourselves to the periodic table. Oh, there's my small one over there, so I have to turn around. Okay. So I have to turn around all the time. I'm going to use this. See, oh, this will work out real good. I'll actually use my little whiteboard here that I can write answers and turn around like that, and you can double check them too as well. All right. So, okay. So I have my little pocket periodic table there, so I don't have to turn around and make it a little easier. So if you're looking at your worksheet that I gave you, okay, or that I assigned to you there, all right, it basically told you to complete the chart and it gave you 4 elements. It gave you carbon, sodium, arsenic, and strontium, okay? And for each one of those, you were then needing to do the atomic number, atomic mass, the number of protons, number of neutrons, number of electrons, valence electrons, the number of energy levels, and then the last one was probably one that was difficult, which I'll explain kind of what I wanted on that, or hopefully if not, but you'll know for the next one for practice. How does it become an ion? And if you remember the definition of an ion, referring to a charged particle, that's when you really start getting into where we talk about those pluses and negatives, how many extra electrons it has in that outermost shell that either it's wanting to fill up to be stable or to get rid of to be stable, okay? Meaning, that's the key thing. It's all about the pluses and minuses, or kind of like opposites or negative, kind of like magnets and stuff. So that's kind of the basic principal properties on kind of why some elements bond well or better with others, or why some are a lot more reactive or volatile or dangerous, however words you want to use it, okay, in different capacities, okay? All right, so let's look at the first column there of carbon, okay? And I'm going to write on my little whiteboard and turn it around here, and that'll actually work out pretty good. Do I have my little rag here too? Whoop, one second, I dropped my rag over here. I got the spray. Oh, it's over here. 1 second. Oh, there it is. There she is. Got it. Okay, got it, so I can wipe on it. Okay, so basically that first column there with carbon, okay, all right, if you're looking at carbon, all right, you have, first things first would be atomic number. So when you're looking at your periodic table, remember the atomic number is where it's found in the periodic table, okay? So checking your atomic number on that should have been 6. Why? Because it's element number 6 right here. The atomic number is also where it's located on the periodic table, okay? So that first blank, I'm trying to find a good pin that writes here. So, okay, so the first blank, oh, that's better, should have been the number 6. And then its mass number, if you're looking at your carbon there, that is, remember, protons plus neutrons. And I said round up, so if you didn't round up, that's okay, but you would have had the number 12, okay? So it would have been the second number there, mass number would have been 12, which if you look at the periodic table, it has 12.011, which rounds up to 12, okay? So then, of course, the next question was how many protons? Well, protons and atomic number are the same, so it would have been 6, okay? All right. Number of neutrons is you subtract the protons from the atomic mass. So you're going to subtract the protons, or the atomic number from the atomic mass. So 6 from 12 is 6, so you know that it has 6 neutrons, okay? So then it wants to know how many electrons does it have, as it says in the column. Of course, electrons and protons are equal because it's not a charged particle, so if it has 6 protons, it has to have 6 electrons, okay? I'm going to turn this around so you can then check it like that. I'm just writing it once, so I don't have to keep flipping back and forth, okay? Then it brings us to the last 3 ones that you might have didn't review on like you would have liked to or needed me for that purpose. That's why I wanted you guys to see really where we needed to focus on, okay? Talked about the term valence electrons, okay? Remember, those are those extra electrons that will spill over into the element, okay? I'm sorry, spill over into the next level. So I'm dealing with carbon. Now, if I have 6 electrons, that means that first orbit, which I also help you with that, holds only 2 electrons. So that first little orbit, okay, dot, 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 if I'll make mine with a dotted line, doesn't matter, can hold 2 electrons, okay? So then that means if I still have 4 more to go, those 4 then spill over into the next energy level, which can hold up to 8. So basically, valence electrons is another word for extra electrons that does not fill up this thing. So it should have 4 valence electrons because it had 6 total, so 4 spilled over, okay? Remember, I also use that analogy like putting people in a car. I can put a driver thing, the rest of you pile in the back seat or the next seat like that, okay? So valence electrons column should have said 4, okay? Then it asks you how many energy levels. Well, I just kind of told you there as well. So the first energy level, member fills 2 electrons, and then the next 4 spill over into the next one that can hold up to 8, but it only has 4, but that's still two circles or 2 energy levels. So that means it has 2 energy levels, okay? And the last column, this is the one that was really tricky, it says, how does it become an ion, okay? So carbon, being right here at that plus or minus 4, it's right in between because it's at that breaking point where I either give 4 electrons away or I take 4 electrons. So it's that tweener. So that's why I have the plus or minus 4, okay? So for that question, I would have put the term, like you wouldn't have done this, probably plus or minus, and just what does it normally have as a 4, okay? And then I dropped down and did the diagram, which would have looked like this. I'm going to turn this around and let you guys, and I'm going to walk you through it with my pencil. So protons would have been 6, neutrons would have been 6. So my first carbon column, all 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Plus my diagram, guys and gals, would have looked like this. Okay, hopefully you can see that. Okay, so first things first, if you look at the first one here, right here, atomic number should have been 6 because that's the 6 protons. Okay, the second one is the atomic mass, like I said, should have been 12, which is protons plus neutrons. Okay, the third row, then I asked you then how many protons again, I believe was 6. Okay, then of course subtract atomic number from atomic mass, and that gives you neutrons, which have been 6 again. And then which protons equal electrons, so that would have been 6 electrons. Okay, so then it was asking about the valence, which I was explaining about how many spill over into that outermost level. They had an extra 4, so it has 4 valence electrons. And then the 2 is how many energy levels. It took 2 circles, you see here. Here's 1 circle. I did a dotted line, I stopped doing a dotted line, okay? And that would be like the diagram below. And then the last one, like I said, it's kind of a plus or minus, meaning it can give or take, and then it has, you know, a plus or minus 4. But more importantly, the little diagram. See a little circle diagram, okay? So you see, this is what your diagram should look something like this. Should have been a simple diagram of, I just put P for 6 protons, N for 6 neutrons, and then there's my first energy level, 1, 2 electrons for the first energy level, just like I said, because that's 6 total. Then the next energy level could hold up to 8, but the 4 spilled over, so that's where I get my 4 valence electrons, okay? So your first column should have looked like that, all right? Should have had these 7 numbers, and then that's what your little drawing should look something like. If you did a little different, maybe a little fancier, maybe you did a bunch of pluses, it's all the same, but it should have looked something similar like that in 2-dimensional little drawing, okay? All right? Okay, so now I'm going to erase this one, and I'm going to go to the next one, sodium. And I'm going to do the same thing with you, okay? And I'll write it up there, okay? So sodium, which is Na, of course. All right, sodium. All right. That gives me, again, 1, 2, 3, 4, 5, 6, 7, 8 columns. So looking again, first things first, sodium should have had 11. Okay, that's where it's at on the periodic table. So I can turn around here and take a real quick peek. Sodium, 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 8, 9, 10, 11. Just go over here. If you can see that all the way. Actually, my camera's a little off there. Okay, sodium's clear out here. Element number 11. Okay, so it has 11. Okay, so it should have been 11. So then total mass would have been 23, which was 22.9. I rounded up to 23. If you left it at 22.9, that's okay. But just go ahead and round up to the whole number. It's easy for what we're doing. So it should have been 23. So then, of course, the protons is 11, because that's its atomic number. Then I'm going to subtract 11 from 23 to tell me how many neutrons. So 11 from 23 is 12, if my math's right. Okay. So then protons equal electrons. So the next column was electrons. There's 11. Okay. So then now we're talking extra electrons, which is my little circles. Okay. So if I have my nucleus, my first energy level gives me 2 electrons. Then my next energy level, like I said, can hold up to 8. So that'd be 8 little e's. 1, 2, 3, 4, 5, 6, 7, 8. And then it's full. So that means I got to add, whatever's left goes over to the next energy level. So 8 plus 2 is 10, and I have 11. So that must mean I have 1 extra electron that spills over. So valence electrons should have been 1. Okay. So then that gave me 3 circles. The first circle was 2 electrons. The second one was 8. And then I needed 1 more energy level for that 11. So that gives me 3 energy levels. Okay. Hopefully you're all staying with me. All right. And then last but not least is how does it become an ion? Well, think about this. It's going to, even though it's a plus charge, a +1 charge, it wants to lose an electron. Because think about it. If that third energy level, okay, can hold 8 electrons as well, because it goes 2, 8, 8, 18, 18, and I'll explain that. Okay, that's not a big deal. But isn't it easier to get rid of 1 than try and find 7? So that's the whole mental thinking of that. So, all right, to lose 1 and then gain, all right, is the same thing, right? So protons is 11 and neutrons would have been 12, okay? So here's what we got. All right, so I just did dotted lines for my 3 orbits here. So once again, hope you can see that. Hold it there so it's nice and squared up to the camera. All right, so sodium, 11 protons. 23 is the mass, so there's 23 for the number, which remember is protons plus neutrons. 11 for the protons. Subtract that from this, gives me 12 neutrons. Okay? All right, so then obviously protons equals electrons, so there's 11. I showed you with the energy levels, 2, 8, and then 1 spills over, so that gives me 1 extra electron, which gives me 3 circles, 1, 2, and 3 energy levels. And then I explained about what has become an ion. Remember the term ion means it's charge. So by it having that +1 charge means I would rather get rid of this and share it, because then I'd be nice and stable, than try and find 7 more to fill that level. So what does that tell you about sodium being a +1 charge? It's very reactive and it bonds well with other things that have a -1 charge, meaning they're looking for an extra electron. So sodium is a very reactive substance because the lower the charge, the more reactive it is. A lot of times it's because it is. It's easier to get 1 electron or 2. It's as you start getting up into higher plus, it makes it a little harder, or okay, a little more things for it to find to react with. Okay, and then your little picture should have said, if you can read that, P in the nucleus, P11, so 11 protons. We did 12 neutrons. Remember, if I add those up, it gives me 23, which is atomic mass. That's what's in there. Then here's my first orbit. Can hold 2 electrons, 2. Then I got 8 little e's for the second. And then that 1 spills over for the third. So there's what my little electron configuration picture should look like. Okay? 2, and then 8, and then it would have been 8 again. Okay? All right? 2, 8, 8. All right. Okay, all right, so that's that. All right, so we're going to move on to arsenate. Any questions so far, troops? there any questions so far, just stop me, okay? Because I know you guys are experts at this, and I'm assuming if you're not asking, then you're like got this mastered down, or as I'm not only telling you, showing you and walking you through it, that's helping clear up maybe some of those few questions you might have, okay? Because we want to make sure we got these basics down, because getting familiar with that periodic table makes it so much easier as we continue working with the stuff for this unit, okay? All right, so let's go to arsenic. Arsenic, okay? All right. So first things first, arsenic is element 33 there. So you see it, it's over there in, right? Bang, 33 right there, okay? There's arsenic. So it has an atomic number of 33. Choo. And then, of course, its mass number, if you look, reading it, getting used to it, 74.9, so we'll call that 75. Okay? So then we need to do, so protons, if it's element 33, it must have 33 protons. So then I'd want to subtract that from the atomic mass to give me my neutrons in there. So 33 from 75 is 42, guys and gals. Okay? So then, obviously, remember, protons equal electrons. So that means I have 33 electrons. Okay? So then if I start doing my little orbits, okay, now when I start getting larger amounts of electrons, do not let it confuse you. It's just the same format. We fill them up. Next level, fill them up. The only thing you'll probably forget, which I will tell you, is how many electrons go in each level. All right? And I actually, for today's assignment, as practicing, I wrote on the outside of one of the worksheets that'll be in your Google Classroom, the energy level, it actually goes 2, 8, 8, 18, 18, 32. So as those energy levels, and we don't go past that. So that'll help with that too as well, okay? So, where was I? 33. So valence electrons. So if I'm doing my energy levels, okay, and I do my little circle. So I have my first energy level there, has 2 electrons, which makes 2, okay? I'm going to make a little tally here. So first level has 2 in it. So the next level has 8. 8 plus 2 is 10, okay? So that's 10 total. So then I said that next energy level is going to have 8 again, okay? So it goes 2, 8, 8. So if I add 8 to 10, that's 18 total, all right? So I have 3 energy levels full, and I'll show in the diagram. I have 3 energy levels full, and I've accounted for 18 of the 33 electrons, okay? So then my next one is 18. So then I'm going to take 18 plus 18, which is 6, 1, 2, 3 is 36, okay? All right, so what that does is, all right, if that means 18 and 36, okay, so that puts me over by 3. So I don't need to fill up that entire extra electron. So that means if I can fit 18 into that 4th level, okay, which would give me 36, I only need to put 15, right? So because if you do the math, right, if I have 18 and I'm looking for 33, and I put the rest of them in there, okay, 9, 10, 11, 12, 13, that's 15. So that means in that outer shell, that 4th energy level for arsenic, if I follow me, that can hold up to 18, I only needed 15 spots. So that means I have, as you know, 3, okay, all right? And I wrote that wrong on my sheet. So valence electrons, how many extra electrons does it have? Okay, I wrote down as far as 3, as meaning how many has left over there. It actually has 15 extra valence electrons in its outer orbit, because if it's not full, I just caught myself there. I put 3 because I'm thinking charge. I should have wrote 15. So let me get my pen here real quick and fix that for arsenic. So valence electrons, let me get my correction tape here too. See, I just caught myself. I was going so fast, I actually caught myself there because it's easy to do. Where is my correction tape? Correction tape, oh, there it is. It's easy to do. You see what I did there is, remember, valence electrons are extra electrons that spill over into the next shell that don't fill it up, okay? So 15 total spilled over, so I was thinking 3, not charged, so it should have been, so your valence electrons, hopefully, you should have had number is 15, okay? So it would have been 33, and then instead of 3, which is what you're looking to fill it, it should have been 15. Okay, oops, tape work. All right, technology. All right, okay, which is a common mistake, and I caught myself just there doing it, okay? So then, how many energy levels did I need? Well, I filled up the second one, the 2, then I had 8, then I had 8 more, and then I didn't fill up the 4th, so I had 4 energy levels, 2, 8, 8, so 4 circles, like Saturn. So my energy levels would have been 4. And then the last question was, how does it drink? So that means if it has 15, I'm looking for 3 to fill it. Even though that says it's a -3 charge, it's the opposite. So I want to gain 3 electrons, okay? So it wants to gain 3 electrons. So let me make my little drawing here for you troops. So it's going to be this, which is going to have 8. 1, 2, 3, 4, 5, 6, 7, and 8. And then I got another energy level that's going to have 8 more, the third one. 1, 2, 3, 4, 5, 6, 7, and 8. And then my 4th shell, which could hold 18 up there, but I don't need it all. I need 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can count. 13, 14, and 15. Okay? So, boom, there you go. So, let's walk through this one again. So, arsenic, element 33. Okay? Atomic number. Atomic mass is 75. Okay? Then it says how many protons, which is the same as the number, 33. So then I subtracted 33 from 75, which gives me 42 neutrons. So remember, protons equal electrons, so 33. So then this is where, like I said, I had 15 that spilled over into that last level, so their valence, that's extra. So I should have had 15 valence electrons, not 3. I want 3 to fill it, but I actually have 15 extra, which then gave me 4 energy levels. And I even showed you over here, 2 can go in the first level, which did, then 8, which gave me a total of 10, then 8 more, which gave me 18, and then in the 4th level, I can put 18, but I only needed 15. You add up those numbers, that gives me 33, which is the number of electrons. And then, like I said, which gives it a -3 charge, troops. Remember, it's right here, arsenic, -3. So what that's telling me is I want 3 more electrons to fill that outer shell. That's what it's telling me, guys and gals, okay? All right, oops, I didn't write down in here. And then you would have wrote P33 and N42 in the nucleus there instead of having to make all the little hash marks, okay? But everybody can see that, all right? So that's what yours should look like. If not, and I'm moving a little quick, that's why I'm recording this, all right? So you can see that, and we're good to go, and you can check if I'm moving a little quick or if there's a question that comes up and you're shy about asking it or not thinking about it now and want to later, you have this to refer back to, okay? All right, last but not least, moving well. Okay, any questions so far? Here's number 4. All right, let's work that. Ugh. There we go. All right. Dun, dun, dun. Dun, 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 dun. So number 4. All right. So last but not least of the Mohicans here is strontium, and it's a another bigger element. Okay. So strontium there. And strontium is right there. And the second column, element number 38. So that starts us with the first question. Should have been number of protons, 38 troops. Okay? Then the atomic mass was the 88. So if you look at strontium, was 87.6. We rounded up to 88. Okay? If you didn't, that's, remember, we're just rounding up to the first whole number. Remember, 88. So just because the numbers are getting a little bigger, meaning we're getting farther down here with bigger elements, doesn't make it harder, okay? It's just bigger numbers. It's the same format, same principles, okay? All right, so then that makes, if that 38 protons, because that's its atomic number, then I need to know how many neutrons, so subtract 38 from 88, okay? Which gives you 50, my math's right. Remember, if my math's wrong, okay, you guys holler, okay? So if the protons is 38, that must mean I have 38 electrons. Okay, so I have 38 electrons. Okay. All right. So now it needs to know how many valence electrons. Well, let's just do that on paper here real quick. All right, so my first energy level, remember, takes 2 electrons. So first energy level, that's 2. Next energy level takes 8, which makes 10. So then my second circle, 1, 2, 3, 4, 5, 6, 7, and 8. My third circle has 8 again, so 8 makes a total of 18. So I make my third orbit. 8 more E's, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so then my fourth circle can hold up to 18. And if I do my math right, and I'm looking for 38, okay, all right, 38. So that means at this point I got 18. So what's 18 from 38? So 38 minus 18 is 20. Oh, well, that's cool because that next level can hold up to 18 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 puts me at 36. Is that right? 36 total. So 18 and 8, 18, that's 36. So that means I need 38. So my next energy level again is 18. But all I need is 2 more. So that means I got another energy level. And those last 2 electrons spill over into that. Which makes sense, right? Because look, I'm at a +2, even though it's a monstrous thing. This tells me I have 2 extra valence electrons because of where it's found in the charge. So I just got an extra energy level, all right? So that means, what is my valence electrons in this particular case? All right, was 2. Okay, 2 extra ones spilled over. All right. Then how many energy levels did I have? 1, 2, 3, 4. Looks like 5, right? Everybody have that 5 because I had the 2. Second level has 8, then had 8, then had 18, and then 2 more spilled over into that one. So yes, maybe 5 energy levels. Okay. And I caught another little typo with me. I put 4 because I was not thinking right. See? Okay. All right, so should have had 5. All right, and the last but not least was because it has a +2 charge for the ion, is the same as saying I want to lose 2 electrons. Okay, so here we go. Bam! So once again, running through that. Atomic number, 38. Atomic mass, 88. Okay, then we got number of protons, 38. Okay, so subtract that from that, gives me 50 neutrons. Okay, make sure we can see that there. Okay, all right, so 50 neutrons. So then protons equal electrons, 38. So we did the little circles here, which I was doing that with you at the same time. 2, 8, 8, 8, that gives me the 2, so that's why it gives me 2 valence electrons, which is the same as saying 5 energy levels. 1, 2, 3, 4, the 5th one, 5 energy levels. So that also gives it a +2. Is the same as saying I want to lose, because it's much easier to lose these 2 electrons than to find 16 more electrons to fill it. Okay? Get rid of the 2 in order for that. Okay? All right. So, and then you would have had P38. And I'll write it down here since it's so thing. But your protons, you should remember, should have had a P38 and N50. Because I wrote so small there, but remember, you would have been that inside the nucleus. Normally, you make your nucleus big enough to where you could do that. And you don't have to make 38 pluses and N's. You can just do P, that, for so on. All right? So there are the answers to this worksheet. Okay? All right. And I will scan this too here later today, though, that way. But you have them all right here. Hopefully, guys and gals, you guys... You know, if you made mistakes, that's perfectly fine. I don't care if you made mistakes on the whole one, like I said, though. But, and I'm not calling anybody out, but I sure hope you gave me effort, like that's all I asked. I said, give me an effort to see where you stand on this. And like I said, if all you got past was, okay, I know atomic mass, I know atomic number, I know that, but once I got to the valence, I couldn't remember all that, that's fine, okay? That's why I went back over it, because, all right, this is important. Oops, this is important stuff that we need to just keep the basics of chapter 4 that we learned right before Christmas, all right, that we need to go back over and keep that with us, okay? So, all right, so here's, not to be moving forward too fast, okay? So what I did is exactly what we practiced and what I just went over in its entirety. I uploaded 2 of the same looking grids, and you have 8, 4 on each, of course, 8 new elements to do the same format with. So, watching the video, listening here like all you guys are logged in, plus me showing you, I'm right there as if I was looking over your shoulder at Miss King, but these guys and gals are going to be graded yes or no, right or wrong, because you are experts now, not only because we went over it to make sure, we videoed this, we showed you the answers to that, but now I need you to apply it between now and Wednesday, okay? So the elements you have on there, you have potassium, okay? Cesium, oxygen, argon, you know, here they are, you know, here's potassium over here, there's K. Cesium will be your biggest one, that'll be your biggest one, 55, all right? And then there's argon over here, okay? And there's oxygen you do. So, I mean, I picked, you know, there's aluminums on one of them. I think I also picked boron, but you have the same format, okay? If these boxes are too small for you to do your circles, I don't know how some of you are good at drawing, you can do them on the back on a different piece of paper. If you needed to make bigger circles to draw out your little configurations, that's perfectly fine, okay? But this is something that I need to make sure that we're 100% on, and we're getting good, because the only way we remember atomic number, we just have to completely remember. But it just comes like, oh yeah, atomic number, that's this. I know where to look on this, because Myers said, always I can have this in front of us. Yes, you can. You do not have to memorize this. You just need to know how to read it, okay? And that's what this is more practice of, because we haven't had a lot of time with it. But this is nice with the video. As much as you may or may not want to watch them, this helps with you recall. Or when you tune out and go, oh, look, a bird, and then you missed if you were sitting in class for 5 minutes, not on purpose. Now you always have the luxury to go back and watch that if you forgot one of the properties or principles or rules or whatever, okay? Or if you just fell asleep, or you got your camera off and this and that, and you're sawing logs right now, right? You have this, there's no excuse for you then to say, okay, if I'm doing all that, boy, he's a smart one. I then can go back and look at this. There's no reason I shouldn't be able to be able to do this, if that makes sense, okay? So that's why I'm taping that too. That's why I do like that part about it, is taping that stuff, okay? So, does anyone have any questions? My FPC flock that's doing so well and everybody's looking at me, right? Anybody have any questions, okay? All right, all right. I'm going to shut off so I don't eat up any more memory. I'd be really upset if I lost this whole lecture because I covered it. So I'm going to shut the camera off real quick, which is the video lecture, and when I'm done with you guys here, I'll upload that and I'll put it as a title. This was what you guys just had exactly videoed, the examples and so on that you guys listened to lecture, so you can go back to and refer to it. All right, I'm going to shut this off now.